figured I would go ahead and show you actually one of the inspections that I have been doing out here. So for the last 3 months, we have 5 sites that were side by side, 2 of which we're still waiting to start. So 3 have been constructed, and my job is to go through those sites and, like I said previously, do inspections, specifically in this case racking inspections, the structure that holds all the solar panels up and together. So this racking system we're working with is known as Solar Flex Rack, and as all racking systems are, every bit of racking system has its pros and cons. This one, some of the cons are that it is a little less tolerant for sloppy installation. Requires a little more attention to detail. Other than that, I mean, it's a good system. It's quick and easy put together, but you do have to pay attention to details. So because of that, normally we only do inspections at somewhere around 10 to 20%, maybe 25%. So I'll just hit some here and some there just to make sure that, you know, it's being done properly. This racking system, because of its quirks, we went ahead and decided that we would inspect every single racking pile out here. By the way, in case you hear me say the word pile, I'm not talking like piles of dirt. I am talking metal piles like this. That is a pile. And what I am specifically inspecting on this particular racking system is going to be this whole assembly right here. Make sure these dampeners are spaced properly, which, by the way, is only on the 2 outmost posts. So the middle posts don't have those, so I only have to worry about that out here, even though I do inspect all the other posts. But we have to pay attention to these things. So really quick, what I'm looking for specifically is this particular system requires a method called turn of nuts. Now, normally when you tighten these up, you have a specific torque value. You tighten it down with your torque wrench, and it'll click or break or whatever when you reach your torque value. This is a little bit different. This is, you tighten it as tight as you can with one good arm, and you put the mark on it all the way across, and then you move 2 faces past. So 2 corners, 1, 2, and then, or faces. If it was here, you go 1, 1, 2. Anyways, so 2 turns. And as an O&M guy, I very much prefer torque values because I can check those. I can come along with my own torque wrench, is it right? But this comes actually, surprisingly enough, this method comes out of building bridges and other very large structures. And the whole point is any spot where 2 pieces of metal may slip against each other, this method is used. So places like this, okay, those will never slip against each other. You can't have those slip. So you don't have to worry about it here. Same thing here. This will never slip. See? So you don't need to put those on there. So we check for here. We make sure our turn of nut is correct, in which case they are. See? 1, 2. So it's a little, just a hair over tightened, but that's actually pretty normal. So same thing here, 1, 2, just little. So we're good here, we check these down here and make sure these all have torque marks, and make sure the turn of nut is correct down here and down here. Same thing up here, make sure all the hardware is in place. Look here, basically any bolt that has been installed in the field must have a torque mark. So I look for those, make sure that they all have torque marks. They do. Great. Okay, so now when I'm done that, and I've done that, I look to make sure that, and this is one of those quirks that really screws people up, is a lot of times you put all your stuff plumb to the pile, okay? That's pretty standard. In this situation, you need to put it plumb to the torque tube. So if the torque tube is sloped downhill because of terrain, this whole thing would need to match. It'll look crooked on here, but that's part of the design. So hey, okay, whatever. So I make sure, and now, if you actually look at this point right here, and this point right here, they should be level across with each other. So that means that these 2 points should touch this line right here at roughly the same time if we move down. And you'll notice that they do. See? They do. Now, I know there's probably a proper term for that, but I call it a shadow line test. I don't know what else to call it. So this is plumb. So I know this is okay. So good. Great. Now, I would, of course, measure the gap distance here to make sure that it's within tolerance. And if it is, that's great. Now, then I'm going to measure this distance here to here to make sure that this is spaced properly. And the distance from here down to here, because this dampener will only stretch so far and it'll only compress so far. So we need to make sure that this distance, this whole dampener distance here, is within tolerance. Because if not, when the roll rolls over, it'll smash it. These are oil filled, so it'll blow out the oil. If it's too far, it'll stretch it when it switches in the other direction, because all these rows roll from east to west by a good amount. So yeah, and of course, if I find any issues, I flag it, I'll make notation of it, and then that goes into our reports for inspection, and then from that we'll generate a punch list for items that need to be done.